Hello, fellow math contest enthusiasts. Welcome back for question number 24 on the 2002 Cayley competition. So what does question 24 have to say? A cylinder, which has diameter of 27, which we got listed up here, and a height of 30, contains two lead spheres with radii 6 and 9, just as we've got shown here, with the larger sphere sitting on the bottom of the cylinder as shown. So they've been plunked in and they're resting on the bottom. Okay. Water is poured into the cylinder so that it just covers both spheres. The volume of water required is, and then we got a bunch of answers, all of them in pi. That makes sense. We should expect some pi's here because it's going to take the shape of a cylinder, basically when the water is all filled up. And the formula for the volume of a cylinder has a pi in it. And we'll also have to remember to subtract off the volumes of the lead spheres, because they're taking up space in there. And that formula also has a pi sitting in it. So we should get a bunch of things with pi's in them, canceling out. Okay. So, if we wanted to do this, let's draw ourselves a bit of a picture. I'm not going to draw a 3D picture. I'm just going to draw a side view picture just for a moment. And hopefully I can draw a straight line. So we have a big circle here on the bottom. And then we have the smaller circle which just touches. Okay? When I look at it from this side, there's something that often happens when we have circles that are just touching. You want to connect up their centers. So we'll make the bigger one blue. We've got a bunch of 9s. I always connect centers up to tangency points. Always, always, always. So I should probably make this green. I'm going to use blue for the water. And then we'll have red. So since the circles are resting against each other, they're going to, and they're settled on the bottom, they are going to touch the sides, and this bigger one's going to touch the bottom. We'll get some 6s here. Okay. So we have some height here. And this height is something we want to work out because water is going to be poured in and it's going to fill up all this area all the way up to this top height. So if we knew the height here, we could say the water is, well, what's the formula for the cylinder? So we know the diameter is 27. So radius is half the diameter. So radius is 27 over 2. So the volume of the water is going to be pi r squared h. That's if we just took it as a cylinder of pure water. And we're going to have to subtract off the volume of lead spheres. Okay, so we know what r is. It's 27 over 2. Because we have the radii of the spheres, we can figure out the volume of the lead spheres. So let's do that now. So the volume of a sphere is something that you should hopefully know. It's 4/3 pi r squared. So for the smaller circle, radius of 6, so 6 to the power 3. And the bigger sphere is going to be 4/3 pi 9 cubed. So we did all this work, and now we know what we're looking for. So to find the volume of water, we need to figure out that height h, that point where the water just fills up just to the top of the sphere, or the top of the spheres. Okay, it'll go, I think, to the smallest sphere. I think that's clear from the both their picture and my picture. And so we need to figure out that h, because that's the only thing left in our formula we don't have. We have the pi, we have the 27 by 2, we have the 6 and the 9, we have the formulas for our spheres and our cylinder. We just need that height h. And when we do this sort of analysis at the start of the question and we identify what we need to find, That makes the problem a lot easier to solve rather than just aimlessly trying to figure out anything that we can about the situation. Now, if you're stuck, of course, just try and figure out any calculations that you can, any lengths or any areas or volumes that you can in these sorts of questions. But if you take a moment and draw yourself a picture and say, okay, how would I get this volume? In this case, it's the cylinder of pure water minus the 2 lead sphere volumes. That presents us with, we just need that height h. That's all we need. No other information, just this h. Let's find out what h is. Okay. So if we just want this value h, how can we figure it out? Well, I'm going to draw my picture again, but without all that water in the way. And I'm pretty sure that this point of tangency is going to come into play. Because it almost always does anytime there's a question like this. Okay. So we know that lines from the radii meet their tangent lines and meet their points of tangency at a right angle. And we can and the sphere, the centers of the spheres connect up here. We also have another right angle here. And we have a 9 here and a right angle here. Okay. And the height right here, we go right up 6 there. The height, it's just at the tip, so just at the tip of the sphere of radius 6, so it's also going to have a right angle here. Okay. Well, we've got a 6 here, and a 6 here, and we've got a 6 here. We've got a 9 here, and a 9 here, and a 9 here. Which means overall we have a length of 15 here. We have a 15 on a slant. So if we want the height is sort of 6 plus this 9 at the bottom plus sort of how high up this slant goes. And when we draw this in, you see we're going to have a right angle here. So we have a right angle triangle with a hypotenuse of 15. Okay. Can we figure out maybe, if we knew, so h is 6 plus, let's call this y and this x. 6 plus y plus 9. So if we worked out what y is, I'm using a lot of black, so I'm putting some things in orange. So if we knew what y was, we'd be all set. Well, we know we've got a hypotenuse of 15. It's a right angle triangle. So if we want to figure out y, if we knew what x was, we'd be all set. So we need to try and figure out y on its own, which I don't think we have enough information. Or we can try and figure out x. Now x neatly bridges the gap from this point, 9 here, to a 6 here. And that gives us the whole width, or I guess the diameter of the cylinder. So we have a height here. We also have a diameter of 27, and 27 is 6, plus that x value plus 9. So that's x plus 15. So x is going to be 27 minus 15, 12. So x is 12, and we've got a Pythagorean triangle here. (15) and x. So by the Pythagorean theorem, x squared plus y squared is equal to 15 squared. Well, I know what x is. So this is 12 squared, 144, plus y squared is 225. And we can rearrange, and we'll see that y squared is 225 minus 144. But that's 81. So square rooting both sides, we get y is equal to 9. So the height that we want, the thing that we're interested in, we know that that was 6 plus y plus 9. Well, suddenly that's 6 plus 9 plus 9, and that's a 24. Also, because y is 9, looks like the the center of our smaller sphere is exactly level with the height of our bigger sphere. Interesting fun fact, I guess. Okay, so now we have the h that we sought after. So now we can get the volume of the water, which is what we were asked for. So that's pi. I'm just going to take out the pi's here. 27 by 2 squared h minus 4/3 6 cubed minus 4/3 9 cubed. Okay, so that's 27 squared is 729 over 4 times 24 minus 4/3, 6 to the power of 3 is 216. 9 to the power of 3 is 729. So it's pi, and then what have we got here? 4 and 24 are going to cancel out. That's 6. There'll be a 3 in here that'll cancel out, and we'll be left with 72. And there'll be a 3 in here that will cancel out. We'll be left with 243. So 729 times 6 minus 4 times 72 minus 4 times 243. And now it's just a matter of getting out our calculator or doing our calculations out by hand on a scrap piece of paper. So we'll get 4374. Just this value by itself right now is how much water would be in there if there were no lead spheres, if we just filled it up to a height of 24. And my guess is this will probably be one of the, E. So if you just rushed and you forgot to take off the volume of the lead spheres, you would get an answer of E, and that would be wrong. So you have to take out the spheres. They are taking up space. 4 times 72, so that's minus 288, and 4 times 243 is 972. And now we just need to do this big old calculation. So 4,374 minus 288 minus 972. We get 3114. So writing that the way they did with the pi at the end, we get 3114, and I really hope that's one of the answers. It should be. Should be, and there it is, it's D. So D will be the answer. Fancy that. And that does it for question number 24. It's a nice little question. Things to note here, we had to use the volume of the cylinder. We had to use the volume of a sphere. We had to use Pythagoras' theorem eventually. But the big one that doesn't come up a whole lot, but is still something very important to know, if you see circles and they're touching, connect the centers with their radii. I would say 9 out of 10 times this is going to be a useful thing. And so that's what we did, and that led us to our solution. And I think that was a very nice little question. I think we went through it rather smoothly. So, coming up next, in our very next video, is going to be question number 25, and that's going to wrap up the whole contest. Hopefully you've been enjoying it so far. And I'll see you guys for the next video in just a moment.